Just kind of look over a few things that you should be somewhat familiar with. I mean, here it says find the equation of the line shown or described. Okay, so in A, it's being shown to you. Now, there's a couple ways to handle it, but when I look at this graph, I mean, I clearly have a y-intercept. I don't know why I'm getting this as a 2x plus 1. That's peculiar. Got to probably change that. Um, I guess clearly see that it has a slope of 2, and for some reason I wrote a 1 there for absolutely no reason whatsoever. I don't know why I put that in there. So to make sure to correct that, we can see that the y-intercept is 5. Okay, I have it pointing there. Just kind of strange. Let me just make that correction. So y equals 2x plus 5 is the equation of this, because I can see that the slope, one way we define a slope is rise over run. Rise being how far up or down I'm moving, going from a point to another point on the line, and how far left and right I'm moving is the run. Of course, up is positive direction, down is negative direction, right is positive direction, left is negative direction, those things that you all learn from plotting. But pretty straightforward. Sometimes, though, when you're given a graph, it may not pass through the y-axis at a point you're going to be able to tell. I mean, just like take a look down here. What if it passed through right here? The line. I'm trying to put a nice red dot down there. What if it passed through right about there? Well, is that exactly halfway between -1 and -2, or is it just kind of look that way? I may not be able to say with a degree of certainty, but depending on how well the graph has been scaled. So, I may need to go another method to figure out what the y-intercept is. So, sometimes have to be careful because just looking at it alone, you're not going to necessarily put it in slope-intercept form right away. You may have to use two coordinates and then kind of find the y-intercept by calculating it. For B, we're not shown this line, but we're going to write the equation of this line. Again, when I write the equation of the line, I need at least to find the slope. I need to know at least one point that it passes through. And in B, I know 2. So here's what I'm going to do with it. First, I'm going to calculate the slope using the slope formula. And there it is. Another thing that you're expected to know from your days of working with it, working with slope-intercept and lines and things of that nature. Um, so I calculate the slope of this line to be -3. Now, I will then, since I'm not given a y-intercept, as you can look at the 2 points they gave us, a y-intercept is going to have an x-coordinate of 0, because remember, a y-intercept has to cross the y-axis. If you're on the y-axis, your x-coordinate is 0. So if I'm given a point here, I'll have some students, let's say, they'll take the 7 or the -5 and make that b and call it quits. That's not right, because 7 is not part of a y-intercept. -5 is not part of a y-intercept because their x-coordinates are not 0. So I'm going to have to figure out a way of determining or calculating what the y-intercept is, because it wasn't given to us. But I do have 2 points for the line. If 2 points determine a line, should also determine their equation too. So what I'm going to do, and I'm going to show here, say for instance I'm going to use -1, 7 and use point slope form. I'm going to eventually show you I could use 3, -5, but it won't matter in the long run. Again, point slope is that format you see up there, y minus y1 equals m times x minus x1, where x1 and y1 are the numbers that make up the x and y coordinate of the point it passes through. Keep in mind also that the minus signs you see in that formula are part of the structure of that formula. So, I'm going to be doing y minus the y coordinate, x minus the x coordinate. And what that means, and why you see what I get down here, I get y minus 7 equals -3 times x plus 1. Students get confused with this because they'll say, well, shouldn't the 7 have a plus and the 1 have a minus? No, because I'm supposed to be subtracting the y coordinate. So if I subtract 7, I get a -7. If I subtract the x coordinate, I'm subtracting a -1, and subtracting a -1 becomes adding +1. That goes back to your rules for negatives. So that's an equation in point slope form. And if I want to put it in slope-intercept form, all I really have to do is distribute that -3 to get rid of the parentheses and isolate the y. So if I distribute that -3, I get y minus 7 equals -3x minus 3, and y equals -3x minus 4. When I add the 7 to both sides, that's the equation in slope-intercept form. Now the thing is, as I said, I could have used the 3, -5. And a lot of students will say, well, what if I use the 3, -5? Wouldn't I get a different formula? Yes, for point slope. As I show here, if I do point slope, I'm going to have y plus 5 equaling -3x, -3 times the quantity x minus 3 as being the point slope equation. However, if I go through the same process of distributing the -3 and isolating the y, I get back the exact same slope-intercept form. And that's another reason why slope-intercept form tends to get used more often, because if there's any change between, like if I have any difference between two different equations for a line, then they're two different lines. Whereas if I look at point slope, if I have some differences in them, that may or may not mean that they're the same line or not. So, you can have many different representations for the same line in point slope form, but in slope-intercept form, one equation for every line that could possibly be made.